So let's look for example. Here we are given some data point, yeah. So here hydrocarbon in oxygen, we have hydrocarbon carbon level and the purity, and we have also number of observations, yeah. So here, as you can see, we also already plotted scatter plot given from these data points here. In x-axis we have hydrocarbon level X, and on y-axis we have purity level. So as you can see, it follows some diagonal trend. So using this data, we can calculate this mean value of X and the mean value of Y. Also, we can calculate square of Y variables and the X variables, yeah, given 20 data points. So we calculated these data points, and then using that we might calculate SXX and the SXY. And B1 is can be found by dividing SXY derivative by SXX. And as you can see, we have this value, yeah. And the B0 is a combination from mean value of Y minus estimation of B1 and the mean value of X. And using these values, we can find coefficient B0. So then we can create this linear model by putting to the places B0 plus B1 multiplied by X. So as you can see, we built this linear model that can be used in order to predict next value given new data point, yeah, of X. As you can see, when Y is 89.23%, then hydrocarbon level is X1, which is mean purity is equal to 1%, yeah. So there is might be exist some error, yeah. So we might also tolerate for this error. So here, how we can create unbiased estimator, yeah. So it means we take into account errors that can be missed in our previous estimation. So for that purpose, we calculate mean square error and divide by n-2, which gives us unbiased estimator. So sigma square is equal to 1.18, and we might use this error in our linear model. So this is this sigma square is actually variance of error, which is equal to 1.18. So in general, we understood, yeah, how to find these coefficients in our linear regression model. So we already described how we can find coefficient B1 and B0, and using this we can create linear regression model that can be used in order to estimate or predict given new independent variable. We can estimate a dependent variable Y. So here example code in which we can here importing pandas and NumPy, also from scikit-learn, also importing linear regression model. So here, as you can see, so we reading real estate CSV tabular data, yeah, implemented encoding, and we have, let's say, this kind of data, yeah. So transition date, x2 house age, distance from mass transport stations, and latitude and longitude, and y house price of unit area. Yeah, so our goal is to predict unit price, house price of unit area. Yep, given house age and location, its location. So first, let's create here linear model. Yeah, so here this is how we can create scatter plot, and using this code we, let's say, created this scatter plot in which we have relationship between distance to the mass transport stations and house price of unit area. So actually when here we defined that x is the distance to the nearest mass transport stations, and y is a house price of unit area. Yeah, so actually when we write model.fit method, yeah, using linear regression, actually it helps us to find these hyperparameters that we mentioned before, or coefficients, yeah, automatically. So here just code for plotting this linear model in our scatter plot. Yeah, so as you can see, this created linear model for us. So prediction line, yeah, in which we have distances here from market mass transport stations and the estimation of house price of unit area. As you can see, it's not that much good, but at least it describes some relationship, yeah, but it's not accurate. So let's now try to create multiple linear regression model. Yeah, so here now we also to the distance include house age. Yeah, because we believe house age contributes also to the price of the house. Yeah, so now instead of having 2D plot, we have now 3D scatter plot in which we have data points dependent from variables like a distance to the mass transport stations and the house age. Based on these two variables, we want to predict house price of unit area. Yeah, so our multiple linear regression model is created using the same steps as it was in with linear model. Yeah, now as you can see, more or less we created some hyper plane. Yeah, plane that describes this trend. As you can see, our price of unit area heavily depends on the distance and the house age. Yeah, so as you can see, the newest the house and the close to the mass transport stations, the price goes up. Yeah, and as the house age, but house age, as you can see, even though it increases, but if it's close to the mass transport stations, the price is also high. But at some houses, house age, as it increases and the distance is also far, house price also decreases. Yeah,